In one of the previous lessons, we have implemented the custom Vite plugin, which allows us to import CSV files inside JavaScript modules. Inside of our main JavaScript file, we are importing the file products.csv, and then rough content of the CSV file will be transformed by our plugin and turned into array of JavaScript objects. And from the code point of view, it looks like this. Inside of Vite configuration file, we're including this plugin by calling factory function CSV, which we are importing from Vite plugin CSV file. Let's open up this file and take a look at the implementation. So here we're basically using the hook called transform, which will be called by Vite anytime we are going to import CSV files in ECMAScript modules. And then we're basically converting the raw content of the CSV file into valid JavaScript array of objects by using this function parse. And at the end, we are returning valid ECMAScript module to the client, which contains the data from the CSV file in the form of array of JavaScript objects. And here's how our products.csv file currently looks like, that we are importing in our main JavaScript file right here. And then we're basically injecting the content that we have received after importing that CSV file into the pre-tag, and which is why we're seeing the content of the CSV file on this page. But the thing is that now, if we're going to update the content of the CSV file, it will cause the full page refresh of the browser. And just to see it in action, let's create arbitrary constant plugin and see if this plugin constant will still be available after we're gonna modify CSV file. Let's just go ahead and make any modification to the content of the products.csv file. I'm basically gonna add another row in here. And then in the browser, let's see if the plugin constant is still available. So first of all, we're seeing here that the new line that was added in the CSV file was appeared on this page, but the plugin constant is undefined because browser has made full page refresh in order to update the content on the page. So now we're going to implement support of so-called hot module replacement for our plugin. And this technique basically allows us to update modules that are modified without doing the full page refresh in the browser. It's called HMR, which stands for hot module replacement. And in order to implement hot module replacement for our plugin, we need to use another hook provided by Vite called handle hot update. This hook is going to do a synchronous operation, so let's mark this function as an async function. And as a first parameter into this function, Vite will pass context object. So this function will be called anytime we're going to modify any module that we are currently importing in our JavaScript files. But we don't need to listen for all updates, but only for updates that happen to .csv files. So let's use the same condition we have used in the transform hook and check if modification has been done to .csv file. Only then we're gonna run this logic inside this if conditional. But here, in order to access the file name which was updated, we need to reference property file on this context object. And the way we're gonna implement hot module replacement is by leveraging WebSocket connection and firing custom event to the client by using method send on the WebSocket object like this. And then we also have to specify custom configuration for this event. Let's specify the type, which will be a custom. The event name will be CSV-update. Here we can use any kind of name we like. Later we're gonna listen to this event in the client code. And then we also have to specify the data key. And this key will basically store the content which we're going to send to the client. For now, let's just read the content of the updated CSV file by calling method read on the context object. And since this method is asynchronous, we have to await the response and then assign it to the data property like so. And right after that, just to tell Vite that we are going to take care about hot module replacement ourselves, we need to notify Vite about it by simply returning an empty array from this method like this. So now let's try it out one more time and check if the constant that we're going to declare in here will be available even after we're gonna modify .csv file. So I'm going to remove the last line of the CSV file and check if the plugin constant is still available. So as we can see, it is still defined. That means the browser hasn't reloaded the page. But we also haven't seen any changes to the content on the page, because we are currently not listening to the custom event that we are firing from the server. So this was the first part of implementing the hot module replacement, which is firing an event from the server to the client. The next part is to actually listen for this event on the client side. So I'm gonna switch over to the client script, and in here, first of all, let's check if the object which is responsible for hot module replacement exists. This object is stored on the meta property of an import object. And if so, we're going to register a listener for the custom event we have specified on the server with the name CSV update. And as a second argument to this function, we have to pass closure with one parameter. And this parameter is basically going to store the data that we have specified under the data key while sending this event right here. So first of all, let's check it out what we're going to receive in this data parameter. I'm going to print it out in a console. Let's switch over to the browser. As we can see, currently I have 3 products in my .csv file. Let's go there and change the content. And after that, in the browser, we can see that the console shows new content of the CSV file, including our latest product addition. So now we're gonna get to updates on the actual page, because after CSV file is modified, we need to properly change the content on the page. To do so, in our client script, I'm going to copy this line and paste it into this handler. So anytime we're gonna receive the new content from the server, we're going to update the content of the pre-tag by assigning updated content. But currently this content will be passed as a raw content of the CSV file. But what we need to do instead in our plugin is to actually transform CSV content into JavaScript array by calling function parse, just like we have done in this transform hook. So let's wrap the content of the CSV file in the parse function call, and this way client application will receive JavaScript array instead of a raw CSV content. So now back to the browser and check it out once again. Initially I have 4 products in my CSV file. Let's remove the last product from here and see how it will be reflected in the browser. As we can see, content was changed, and now instead of 4 products, I have only 3, which corresponds to the latest content of the CSV file. And that means that our hot module replacement worked. And from the server via WebSocket connection, we have received updated content of the CSV file in the form of array of objects. And of course now, as soon as I'm gonna do any kind of modifications to the CSV file, instantly I'm going to see those changes reflected on the page. So as we can see, our first product was back. And now let's just do one little improvement to our plugin by passing structured data to the client. So I'm going to send an object with 2 properties. First property will be a URL, and second one data. URL will store the path to the module that was updated, and the data will store the new transformed content of the updated module. Let's just add more descriptive message on the client side in the console and say which module was updated. And here we have to destructure 2 properties, URL and the data. Those are 2 properties we have just specified in the source code of our plugin right here. So now let's check it out one more time in a browser. We'll create constant plugin, and if this constant will be available, this will be a sign that the browser hasn't done full page refresh. So after modifying the content of the products.csv file, we can see that it was reflected on the page, as well as we can see the new log, which shows the path to the file which was updated. And of course, the constant plugin is still available. So our hot module replacement for CSV files works great. And this is how we can implement hot module replacement in Vite projects, by basically using the function handle hot update in our plugin, and then sending custom event via WebSocket to the client with appropriate payload. And then on the client side, we are registering the listener for this event accept updated data, and then do whatever we need with this updated data in order to apply hot module replacement update. So this was one of the ways how we can implement hot module replacement in Vite. Now let's see how Vite allows us to establish client-server communication. Just like in the previous lesson when we were using hook handle hot update to implement hot module replacement feature for our plugin. And in here we were using WebSocket object to send events to the client. And then we also had a chance to specify which data exactly should be sent along with this event. And in our client script, we have registered listener for this event, accepted the data received from the server, and then we were able to do anything we want with this data to implement hot module replacement. But besides using this hook handle hot update, which will be called only when any module that we are importing in JavaScript files will be changed, we can use another hook which allows us to configure the server, and this hook is called configure server, which accepts a server instance as the first parameter. And by using this server object, we can also access WebSocket connection. So just like previously, we can set up a listener for all kinds of events. For example, there is a default event called connection, which will be fired whenever our WebSocket connection will be established. So we can try listening for this event in here, and once we establish WebSocket connection, let's send an event to the client with the name connected. And as a payload we can send simple message, connection established. And now to be able to listen for this event from the client code, we have to register a listener by using object hot. So here we also call the method called on, and as a first parameter we have to specify event name, which will be listening for, and as a second parameter we specify the closure, which will be our event handler. So this closure is going to receive the payload sent from the server along with this event. And now let's see what will be printed in a console. I'm going to switch over to the browser, and as we can see in here we have that message sent from the server once WebSocket connection was established. And this way we can exchange messages between server and the client. For example, let's fire another event as a response to the server with a name ping, and the payload, which will also be a simple message, hello server. And now going back to our plugin implementation, inside of this configure server hook, let's register another listener for the ping event and specify an event handler. This time, event handler is going to receive two parameters, first of which will be the payload sent from the client, and the second parameter will be the client itself. In other words, the object that represents the connection. And inside of this closure we will be able to use this object to send events to the client. So as a response, let's send event with a name pong and the message hello client. And now one more time let's switch over to our client script and register a listener for this event pong by using that same object hot. As an event handler, let's specify the closure, which will receive the payload as the first argument, and print this payload in a console. So now in the browser console we can see two messages. The first one was printed once WebSocket connection was established, because previously on the server side in our plugin implementation code we have registered listener for the connection event, and as soon as WebSocket connection was established, we send the event called connected to the server with the message connection established, and then client has received this event and printed that message in a console. And now to reply back to the server, client sent another event with a name ping and the message hello server. On the server side we have registered a listener for the event ping and also printed the message which will come from the client in the server console. So now if we're going to take a look on the server console, we're going to see here that message received from the client hello server. And finally, besides printing this message in a console, we're also firing another event pong to the client with the message hello client. And in our client script, we're basically listening for this event and printing received message in the browser console, and which is why we're seeing in here a second log that says hello client received from the server. And by the way, all those listeners and events which we have used in here, This call will be executed only if an object hot will be available, because we have wrapped everything in the if conditional. And the thing is that this object hot will be available only during development. So if we're going to build this project for production by running npm run build, this object hot will not be available. So all this code will be basically removed from the production bundle by using tree shaking. So at the end, let's just make sure that this is the case. I'm going to print out simple message in here just to see that this code will be executed. And indeed, we're seeing that log hot in the browser console along with other logs. Because currently I'm running development server, but once I'm going to switch over to the console and run the command to build this project for production, and then run production build in the browser by executing npm run preview, sure enough, I'm not going to see any logs whatsoever. This is because that conditional block which we're checking if hot object is present has not been executed, since hot object is not available in the production build. So this is how we can exchange messages between our plugins and the client code by using WebSocket connection provided by Vite. In one of the previous lessons we have implemented hot module replacement for CSV modules. The way we have done this is by using handle hot update hook inside of our plugin implementation. So in here, whenever .csv file will be modified, we would fire event via WebSocket connection to the client and include all necessary data along with this event so that client could receive this data and then implement all necessary updates. And in this lesson, we're going to see how we can implement hot module replacement for JavaScript files. So I'm going to comment out all these listeners. We're not gonna need them in this lesson. And also we don't need to fire any custom events from our server. So let's just comment out this hook, configure server, which was basically used to fire custom events via WebSocket connection to the client. And before getting to implementing hot module replacement for JavaScript files, let's do a little preparation. I'm going to create new JavaScript module in the root of the project. Let's call this file module.js. And here, let's add some dummy code. For example, let's export constant with the name message and the random string. And also let's add one more export, which will be a default export, also with a random string. And now we're going to use HMR API to implement hot module replacement. And all the code which we will need for hot module replacement, we're gonna wrap in the if conditional and check if hot object is present. Then we're gonna implement HMR so that Vite could properly remove this code when doing production builds, since we don't need to provide HMR during production. So in order to implement hot module replacement for this specific module, we can leverage method called accept on the object hot. So this method accepts closure, which in turn accepts one parameter, which will be updated content of this module. Let's call this parameter updated module, and then print out this variable in the browser console. And just to see it in action, we of course have to go back to our main JavaScript file and write an import statement to import our new module. And regarding all other code, we actually don't need any of that, so let's comment everything out, besides our import. And one more thing before we'll check it in a browser, let's go back to module.js and print something out, so we can see that this module will be loaded. And here we go, we got that log, that means that our module was properly included. And now let's see what is going to happen as soon as I'm going to modify the file module.js. For example, let's change this string, and in the browser console, I'm seeing a different log, which was just modified because after updating this file, this module was executed again. And then we also got this log, which contains updated content of this module in the form of an object. So here we can see a default export of this module, as well as a named export of the constant message. And this log was printed by using this closure that we have passed into accept method. So now if I'm going to modify the value of the message constant, for example, right away I'm seeing the new log in the browser, and this time The constant message contains the new value that we have just updated. So anytime we're going to modify module.js file, we're going to see here new log with updated content of that file. And by the way, all this is happening without full page refreshes. But what if I'm not going to use call accept in this module? Let's test it out. Let's comment out this part. In the browser, I'm only seeing one log, which was printed on the initial page load. But after I'm going to modify the file module.js, in the console, we can see only the new log without all previous outputs. And that is because browser has made full page refresh. So in this case, there is no hot module replacement. And again, if I'm gonna go back to the editor and comment this code back in, then initially here I'm seeing only one log from the module.js. And after I'm going to modify this log, we're still going to see the old log as well as the new output. And in addition to that, we got an object which contains updated data of the module. So in this case, as I'm using accept method in my module, anytime we're modifying module.js, browser is not going to make full page refresh in order to update this module in a browser, because all these updates are happening by using hot module replacement technique. And now let's consider another example. So what if my module.js is going to import another module? Let's emulate this situation. Let's create a new file and call it submodule.js. This module is going to have only one default export of the random string. And then we're going to import this module from within module.js right here. And now let's say we want to monitor changes in all those modules we are importing in this module. So for example, I want to run some code anytime the module submodule.js will change. So in here, I'm going to use another code to method accept, which in this case will have a different shape. As the first parameter, we can provide an array which consists of all those imports we'd like to monitor changes in. So for example, in here, I'm going to watch file called submodule.js. So I'm going to include this name in here. And then in this closure, we're going to receive an updated content of every module that we are monitoring. Since in this case, I'm monitoring only one module, I'm going to destructure this parameter and extract only the content of this submodule file. And eventually, let's see what will be contained in this new submodule variable, which is supposed to give us updated content of the submodule file. And before checking it out in the browser, I'm going to include console log statement inside submodule.js for testing purposes. So on the initial page load, we can see two logs obtained from loading submodule.js as well as module.js. And now let's see what is going to happen if I'm going to modify the content of the submodule.js. Let's change this message, go back to the browser, and here I can see the log from submodule.js again, because after modifying this file, it was executed in the browser one more time, and then I'm seeing another log, which contains updated content of the modified submodule.js file. And that is because in our parent module, which is called module.js, we have registered this listener, which monitors for changes inside submodule.js file. And when the change occurs, it is going to print the updated data of this submodule in the form of an object. And if I'm going to make mistake in the submodule name, and then we'll do any modifications to this submodule, then in the browser, I'm still going to see the log, but this log comes from a different place. It is actually this part of code which prints that log entry. So just to make it all clear, let's comment out this part and modify submodule.js once again. And as we can see after modification, there are no extra logs in the console, because we are no longer listening for changes in the submodule. So let's go back to module.js and fix that mistake in this name submodule.js. And one more time, if I'm gonna go ahead and modify the file submodule.js Sure enough, in the console, we're going to see a new log entry with an updated content of the submodule file. And by the way, if we're going to make any syntax errors in our modules, then that log which is responsible for showing updated content of the module will print value undefined instead. So if we're planning to use this value in our closure, it's necessary to firstly check if the received value actually exists. So we're going to wrap this part in the if conditional. So now if we're going to make any syntax errors in our modules, it will prevent us from potential crashes. And it's actually good to do these kind of checks most of the times. So let's add the same conditional to this closure. So this is how we can leverage method except on the hot object to implement hot module replacement for specific JavaScript modules. Let's keep learning Vite in the next lesson. So by now we already know how we can accept HMR updates by using method accept and apply them to our page. And this method accept has a few signatures. First one allows us to accept updates of the model itself, and the other signature allows us to accept updates from dependencies of this module. In other words, from those modules that are imported in this module, like we're doing in here, where we are monitoring changes inside of submodule.js. But there can be such situations where when modules are updated and updates are applied in a browser, those updates might also leave some kind of side effects. For example, those updates might modify DOM structure or change some data in local storage of the browser. Or even a simple console log statement can also be considered a side effect. And sometimes before applying updates of the module in a browser, we need to run some kind of a code which would clean up those side effects left from previous executions of this module. It might sound complicated, but in fact, it is really simple. Let's consider one example. I'm going to create variable styles, and then let's declare the function addStyleSheet, which is basically going to add styles into head element on the page. So in here, I'm going to use DOM API to create DOM element which corresponds to the style tag. And then we're going to assign arbitrary styles to the inner HTML property. For example, let's make background color of the body indigo and text color will be white. And then all we have to do is to append this style element to the head element, like so, by using method append child. And of course, to apply these changes, we have to execute this function once current module will be loaded in the browser. So let's call the function addStyleSheet right here. And also let's open up index.html, and in here we'll add h1 element. So in the browser we see that those styles were applied, and if we take a look at the head element, at the end we can see that style element that we have just added. So far it looks good, but what is going to happen if we're going to modify the styles in any way? For example, let's change the color on yellow and take a look in the browser. The color was properly applied to the page by using hot module replacement, but in fact if we take a look at the DOM structure, here we have two style elements. So the previous style element was not removed, and the new one was just added. So the previous execution of this module has left side effect in the DOM by adding style element, but right after we have updated those styles, the previous style tag was not removed. So it produced so-called side effect, but we didn't clean up that side effect before applying new updates and inserting new style element. And as you may have guessed, anytime we're going to do any kind of changes to our module, we're going to get the new style element appended to head element. So now let's see how we can actually clean up after ourselves. And anytime we're going to modify this module, the previous style tag will be removed and the new one will be appended. And for that, let's create new function, call it removeStyleSheet. And all this function is going to do is basically remove styles DOM element by calling remove method like this. But the question is, where do we actually need to call this function removeStyleSheet? And since this function has to be executed right before we're going to receive new HMR updates, Vite provides us with another method called Dispose that we also call on the hot object. And the closure, which will be passed into this method, should execute all necessary cleanup code to get rid of previous side effects. So this is exactly the place where we can call our function removeStyleSheet to remove style DOM element. So now before going back to the browser, let's actually reset these styles as they were initially. Let's also do a full page refresh to have only one style element on the page. So now after I'm going to modify this module, in the browser what we will actually see is that before appending updated styles onto the page, the previous style element was removed, because that function removeStyleSheet was executed inside of a closure of the method dispose, which cleaned up our previous side effect before appending new element. And just to see at what time those functions are executed, let's just place arbitrary console log statement into function addStyleSheet as well as removeStyleSheet. So on the initial page load, our module was executed and called function addStyleSheet, and therefore new styles were applied to the page. And after any subsequent modifications of this module, we're going to see that before applying new updates, our function removeStyleSheet was executed thanks to that method dispose that we have called on the hot object. So the previous styles were removed and then the new styles were added. And this way we end up only with one style element on the page. Let's go back to the editor and remove these two console log statements. So by now we know how we can accept hot module updates by using method accept, as well as how to remove any side effects before applying new updates by using function dispose. And now a couple of words about standard Vite events that we can listen to. And there are several events that we can listen to, and all of them are shown on this documentation page. So for demonstration purposes, let's just register listeners for some of these events. As the first parameter, we have to specify an event name. I'm going to use beforeUpdate event. And as a second parameter, we're passing the handler, which is going to take some data received from the server. Let's just print out this data in the console and then duplicate this piece of code a couple more times to register listeners for other events, such as for after update and for the error event, like this. And just to make it clear which console log statement corresponds to which listener, I'm going to add in here labels: before update, after update, and error. So again, initially there are no logs that came from those listeners because none of those events were fired on the initial page load, because they will be fired once we're gonna modify the module. So let's do just that. I'm gonna go ahead and change the color of the background. And then in a browser, we can see that firstly we have received the log which came from the beforeUpdate event listener with some metadata about the module which was updated, when it was updated, and the path to this module. So this log was printed right before we have applied HMR update, and the after update log was printed after we have applied HMR updates. And this event handler also received the same object which describes the module which was updated. And just to trigger the error event, we have to make syntax error in this module. And then in the console we're gonna see that the error was printed, which means the error handler was executed. And the data that we have received in here contains the full description of the error. And by the way, the same error was displayed right here. And this is how we can leverage those default events to be able to hook into HMR process and execute particular code at the different stages of HMR updates.